Okay, today we will going to start exercise 4A. The first question is, find the prime factors of the following. So you have to find out the factors of the given numbers. So you have to split up, in other words, the given numbers into its prime factors. So the first number in the first part is 360. So write down 360 and take out your ruler. And draw the lines like this. And factorize your number. This is the division. We are going to divide, we are going to split up the number into its prime factors. So you have to divide the given number into with only the prime numbers. So look at the unit space. There is a 0, it is divisible by 2. Take 2 as your divisor. 2 1 times is 2. From 3, you will subtract 2. You are left with 1. So make it 16 instead of 6. 2 8s are 16 and 0. Then 0 in the unit space. Do the division with 0. 2. 2 is a prime number. 9s are 18 and 0. Again 0. Use 2 as your divisor. Again a prime number. 4s are 8. Left with 1. So 2 5 is 10. 45. 5 plus 4 is 9. You can divide 45 by 3. 1 is 3. And 1 left, 15. 5s are 15. 5 plus 1 is 6, divisible by 3. Do the division again with 3. 3 is a prime number, like 2. The next prime number is 3 after 2. 3 5s are 15. 5 is a prime number, divisible by 5 only. 1 is 5. 5 1 times is 5. So all these numbers are the factors of 360, and these numbers are also prime numbers. So you can write down your answer as, how many times 2? 1 2 3 times 2 is there. So 2 raised to the power 3 multiply by 1 2 2 times 3 into 5. These are the factors of 360. So you will give the power to the numbers. As 2 is 3 times, you give the power 3 to 2. 3 is 2 times present in the factorization. So give the power 2. 3 raised to the power 2 means 3 multiplied by 3. 2 cube means 2 multiplied by 2 multiplied by 2. And 5 is alone, so multiply by 5. All these are the factors of 360. So you split up your number. You uh, split up your number 360 into its prime factors only, and the process is called prime factorization. This is the first part. The second part is, here I'm going to do it. The number is given to you as 663. Use the ruler to mark the lines. The second part of the same first question, the number is 663. 6 plus 6 is 12, 13, 14, 15 divisible by 3, the number 3 2s are 6, 3 2s are 6, and 3 1 is 3. Now, this number is a prime number having 1 in the unit space. So it is divisible by 13. 13, 1 is 13, and 13 sevens are. Then 17 is a prime number, 71 times is 7. So these are the factors, prime factors of 663 is divisible by these prime numbers, 3 into 13 into 17. There you are left with 9, 91, 13 sevens are 91, and 17 ones are 70. So no power upon any number because they are singular. 3 into 13 into 17. This is the answer to the second part. Third part is 5184. 5184. This is the given number. So you have to factorize to find out the prime factors of all prime factors of this number, which can divide the number. And when you multiply all the prime factors, you get the product, the same product, 5184. So here in the unit place, you have got 4 as an even number. You can divide the given number by 2. So you choose 2 as your first divisor. 2 times is 4. When you subtract 4 from 5, you get 1 here. 11 to 5 is 10. 1 left, 18. 9s are 18 and 2 2s are 4. And in the unit space, 2 is there, an even number divisible by 2. 2 1 is 2. 2 2 times is 4. 1 left. 2 9s are 18. 1 left. 2 6 times is 12. 6 in the unit space again, an even number. You can divide it by 2. 2 6 are 12. You will choose 2 digits at the first place because 1 is not divisible by 2. So take 12 to 6 times is 12. To 4 times is 8. 1 left. 8s are 60. Again with 2. 2 3s are 6. 2s are 4. 4s are 8. 2. 1 is 2. 1 left. 2 6 are 12. 2 2s are 4. 2. 8s are 16. 1 is 2. 81. 8 plus 1 is 9. The sum of digits is a multiple of 3. The number is divisible by 3. 2s are 6. 7s are 21. 7 plus 2 is 9, again divisible by 3. So 9 is there, divisible by 3, again 3 3s are 9, and 3 1 is 3. Now the prime factors are 5184 are, so you can split up the given number. Count twos, 1, 2, 3, 4, 5, and 6. 2 raised to the power 6. Multiply by 1, 2, 3, 4. 3 raised to the power 4. These all are the prime factors of 5184. So you factorize the given number and get its prime factors. The fourth part of question. The next heading is, which of the following pairs of numbers are co-primes? Give the heading by yourself. And in the first part, the numbers are 6 and 8. There are so many ways to find out whether the numbers are co-primes or not. So we will do the long division method to find out whether the number is co-prime or not. 6 1 times is 6, 2 left. So your divisor become your dividend. 2 3 times is 6. It is divisible, exactly divisible by 2. The last divisor is your HCF, highest common factor, 2. And you know that co-primes are the numbers when their HCF becomes 1. When you divide two numbers, so or factorize two numbers separately and their HCF becomes 1, the numbers are co-primes. So if the HCF is different, not 1, any other number, so you will say that 6 and 8 are not co-prime numbers or co-primes. When the HCF of two given numbers is 1, the numbers are said to be co-primes. So if HCF is not 1, the numbers are not co-prime. You have to prove this is the comparison of two numbers. Second part. Thirteen and 64. So 64 is a greater number. We will make it dividend and we will divide it by 13. Do the subtraction in this step. You will get 2 and 1. 12. Then the first divisor becomes your dividend. 13, 12. 1 times is 12. You are left with 1. Now your divisor is 12, which 12 becomes your divisor. Dividend 112 time is 12. So you cross the number and the last divisor is 1. So you can say 13 and 64 are co-primes because their HCF is 1. Highest common divisor is 1, which is common in both the numbers. The highest number, which is common and which is factor of both the numbers, is 1. So you can say that 13 and 64 are co-primes. Third part. Question number 2, part 3. '21 and '24. So 24 is your dividend because it is a greater number. Divided by 21, 1 times is 21. Left with 3, do the subtraction here. Then bring 21 as your dividend. 7s are 21. Your HCF is 3. 21 and 24 are not co-prime. The fourth part of the same question is do this part. You'll do the fourth part and the last part you will do by yourself as before in question 1. Okay. The fourth part is nine and 16. 16 is a greater number, make it your dividend. 9 is your divisor. 1 is 9. Do the subtraction. 7, 9, 7, 1 is 7. 2 is left and 7. 3s are 6, 1 is left. 2, 1, 2s are 2. So your HCF is 1. 9 and 16 are co-primes.